In this video, we're going to see another example of finding a Thevenin equivalent circuit. This one is what I was calling case 2, or in my opinion, the medium difficulty case, where you have both independent and dependent sources. Now, because we have at least one dependent source, we're not going to be able to just combine the resistors together to find our Thevenin. The main way that we're going to be able to solve for an equivalent circuit is we're going to find VOC and ISC, and once we have both of those, then we can go ahead and divide them to find our Thevenin. So let's go ahead and first find the VOC. We copy down the circuit without actually adding anything to it. We are leaving that right side open. That's why it's called V open circuit. But we need to find this voltage across it here. This is where VOC is going to be between these two nodes here. Now, mesh current or node voltage doesn't really matter that much here. We're basically two variables, two equations either way. However, because of where that current source is, if we did mesh current, we'd have to use a super loop. So why don't we go ahead and do node voltage here. I'll choose the bottom to be ground. That means we immediately know this node over here is 6 volts. And we'll call this one V1, and this one V2. Notice that V2 is going to be the same as VOC. And we'll go and set up our equation now for the node at V1. We would have V1 minus 6 over 5 minus 1.5 Ix plus V1 minus V2 over 3 equal to 0. For the node at V2, we would just have V2 minus V1 over 3 plus V2 minus 0 over 4. And then because we have a dependent source, we need to have an equation for the dependent source. In this case, it's Ix. And looking at our circuit where Ix is, it's going to be V1 minus V2 over 3. I forgot to put the equal 0 on the second node voltage equation. So why don't we go ahead and first we can clear out the denominators here and multiply by 12. If I do that and then simplify things, I would have a negative 4V1. I'm going to have a plus 4V2 plus 3 is going to be plus 7V2 is 0. For the first one, if I substitute this in for Ix and then multiply everything by 15, just skip a little bit of the work here to save time. So let's see, when I multiply by 15, I'm going to have a 3V1 there. When I multiply by 15 on the second one, I'd have 5 times 1.5 V1 is going to be minus 7.5. So we have 3 minus 7.5 is negative 4.5, and then plus 5, it's going to be 0.5 V1. And then for V2 here, we're going to have plus 7.5 minus 5 here is going to be plus 2.5 V2, and then 15 is minus 18, so 18 on the right side. I can go ahead and multiply this top equation by 8. That gets me 4V1 plus, so 8 times 2.5 is going to be 20 V2, and 8 times 18 is 144. Add down, we're going to get 27 V2 is 144, so V2 is 144 over 27 volts. And since V2 is really the same as VOC, that means we get VOC is 144 over 27 volts. But of course, that's just V Thevenin. That doesn't give us R Thevenin yet. If we go ahead and now resolve the circuit using the short circuit on the two terminals they gave us, then we'll get ISC, and once we get ISC, we can divide them to find our Thevenin. So we are now short-circuiting these two terminals over here. So ISC is what we're going to be looking for. Let me finish drawing everything here. Okay. Now again, at this point in time, we could use node voltage or mesh current. Doesn't really matter. I do want to point out something though. By putting that short in, that means we have this 4 ohm resistor in parallel with a short, which really means we don't have any resistor at all. If the current's coming in, and it can go down something that has 4 ohms, or it can choose to go to something that has 0, all of the current's going to go down the thing that has 0 ohms. So we're shorting out that resistor. It's essentially not there anymore. And that actually makes it so that we only really have one node here. Call that, say, V. Call the bottom ground. Then my equation would be V minus 6 over 5 minus 1.5 Ix plus V minus 0 over 3. And again, Ix is going to be V minus 0 over 3 here, because the current going right at this point is the same as the current coming down. If I go ahead and plug that in, and just to avoid the fraction there, I'll multiply by 30 this time. So 30 is going to be 6 times V minus 6, and then minus 5V. Alright, so we're plugging this in here. By my 30 is 10 times 1.5, sorry, it's 15 there. Alright, because 30 over 3 is 10 times 1.5 is 15. And then 30 over 3 is going to be 10V. Oops. Plus 10V equals 0. And let's see here, that's going to be 16 minus 1 is going to be V equals 36 volts. Once we find that, we can find our Ix, which is the same as ISC here, being that V minus 0 over 3 is going to be 12 amps. Now once we have our VOC over our ISC, we can calculate our Thevenin here. That's going to be 144 over 27 volts over 12 amps. And that's going to be 12 over 27 ohms, which makes our final Thevenin circuit is a voltage source with 144 over 27 volts and a resistor that is 12/27 ohms. And that is the answer we're looking for.